Oh, you're 7. So the start of this video is a bit different from my other ones because I'm having an absolute nightmare at home right now. It's all gone wrong with my cooking today. All gone wrong. I had a plan. I had a plan, boys and girls. I was going to make some beautiful risotto. I don't know if you can see the word risotto rice here. I've got this nice rice. I know it's been in my cupboards, and I was going to make this beautiful risotto. Just a little pea and ham risotto, some cheese. It's going to be lovely. Really looking forward to it. And I measured out my rice, and I put some water in, and I put in some salt, and I gave it a bit of a mix, ready to just to make my risotto nice. And then I had a look on my rice, and it's, I don't know if you can see that there, but it's the use by date's 3 years ago. It's 2018. 2018. So this is, I'm not going to eat it. It might be okay, but my big problem is that I use really fancy salt, and I don't want to just throw the salt away. I want to get the salt back. Okay, and if I was an everyday person, we'd just have to get rid of it. The salt would be gone. But I'm a scientist, like you, and I bet there's some of you watching this now thinking, I know how to get the salt back. I know how to get that salt separated from the wort, and that's the water. I can separate the water, the rice and the salt. Okay, I can do that. And that's what we're looking at this week, boys and girls. We're looking at particles and how we separate mixtures and the different techniques we can use to separate different substances. Okay, so I want you to think, I want you to write down, or don't you have to write it down, but have some kind of idea. Pause the video here and think, how would I separate? How would I get the salt back, my fancy salt? How would I do it? Okay, what would I do? What would be my method? What would be the steps? Okay, I'm thinking it'd be really good practice just to jot them down. You can do it roughly, but just sketch down a little method. So this is the question, how do we get the salt? Okay, now you need to know some different methods of separating in year 7. Okay, you need to know about filtering, you need to know about evaporation, you need to know about distillation, and you need to know about chromatography. Okay, now if you jotted down an idea talking about filtering and then evaporating, you are 100% right and you should give yourself a pat on the back. If you talked about or thought about evaporation or filtering, okay, give yourself a pat on the shoulder, okay, because these are the two things that really work in separating our rice, water and salt solution. Okay, we filter first, and it's important in the order. We filter first, we filter out the insoluble solid from the liquid, because it doesn't fit through the holes in the paper. The liquid does, the particles are small enough that you can fit through, but these larger solid bits won't fit through the holes in the filter paper. Okay, and then we evaporate. Okay, we evaporate off the solvent, and it leaves behind the solute, which is the salt from our solution that is the mixture of the water and the salt. Okay, so we evaporate off. We're separating by melting points or boiling points really here. Okay, now, so this week, okay, and over half term and the week after half term, you've got two options. You can either complete the practical that's going to follow after this little bit of the video. You'll need to take pictures of your experiment as you go. You might want to annotate them, that'd be wonderful. Talking about what you're doing and why you were doing it. What was the point in doing this particular step? Okay. If you are going to do the experiment, you need to get permission. You need to get permission from a responsible adult at home. Okay, because depending on which way you do it, it might be dangerous, and you'll be using foodstuffs, and you want to make sure you're not wasting it. Okay, now, if you're not going to do the practical part, I would like you to make a poster on particles. Okay, it wants to include a particle diagram for a liquid, for a solid, and for a gas, and importantly, how those change state. So what are those key words that show when it's changing from a solid to a liquid? Okay, I've got a tip at the end of the video if you're going to be doing the poster. Now, the practical itself, okay, is going to follow in a second. Don't get upset or stressed if you're not going to be able to do the practical, that's fine. The poster is just as good in terms of your learning. But there are a couple of things. Just to say it again, you have to get permission. Don't
ruin any food without any kind of permission from somebody at home. Gotta stay safe. I was saying it in the video as well, but if you're going to be heating something, it will get hot. Don't burn yourself. Be careful. Okay, be sensible, and stay safe when you're doing it. So, next part of the video is going to be me separating my mixture. Okay, and at the very end, I'm going to talk through a quick method slide about the different steps to how to separate that method, how to separate that solution.
What I'd like you to do, boys and girls, I'd like you to try and replicate my problem and fix it. I want you to try and do a practical. I want you to try and do an experiment at home. Now, in order to do that, you're going to have to be safe. You're going to have to get the permission from a grown-up, responsible grown-up at your home. They might help you. They might supervise you. They might trust you just to do it. But you need to get that permission. Okay? And you're going to need some equipment. You're going to need some kind of pot. Okay? Some kind of thing that you can heat up. Now, there's two ways we're going to do that. Okay, you're either going to need a pot where you're going to heat up, or you're going to need some dish that you can leave to the side and not have to use for maybe a week. Okay, because that way we can evaporate the water. Okay, but a quicker way is to use a pot. Okay, you're going to need some receptacles. I've got a mug, I've got a bowl, I've got a spoon for stirring and for measuring. I've got my measuring jug that's got my water, rice and salt mixture. Okay, and if we can see the values, we've got about 1/4 of a litre. Okay, 1/4 of a litre of water, so about 250 millilitres. Now, I would not have any more water than that. Okay, I would go less, if anything. I've just made it so it's easy to see on the video. Okay, and I've got maybe 3 tablespoons of rice at the bottom of my measuring jug, and I've got a similar amount of salt. I've got about 3 tablespoons of salt. Okay. Now, you don't have to use fancy salt like me. I would use normal standard salt, or you could use sugar instead. Salt and sugar both work fine. You don't have to use rice. You could use couscous. You could use pasta. You could use anything, okay, that doesn't dissolve in the liquid, doesn't dissolve in the water. Okay. So you couldn't, for instance, use sugar and salt. Okay, you have to use one thing that dissolves in water and one thing that doesn't. And that is all our equipment, apart from this. This is some kitchen roll. You could use toilet paper if you wanted to, or you could use a sponge. Okay, some kind of equipment that we'll use as a sieve. Okay, because that's one of the ways that you're going to be separating the mixture. Okay, so how do we go about doing it? So the first step, boys and girls, is going to be to remove and separate the rice from the water. So the rice doesn't dissolve in the water, it's not soluble. Okay, so we can filter it. Okay, filtering a mixture removes the insoluble part from the soluble part. Okay, so I can do that, and I can put it into my mug, and I can get a bit of kitchen roll. I'm going to fold it in half, and fold it in half just twice, and put a little hole in the middle like this. So I've got just a place where I can pour in my rice, water and salt mixture, so my salty solution and my rice that's not dissolved. I can put that in here, and it will stop the rice going through, but it will let the salty water pass into my mug. Okay, that will be my first step. So that's what I'm going to do. I'm going to pour this in. And the first bit of this solution has gone down really quite quickly. It's moving down like that. Don't know if you can see that. And then I'll put in the rest. I'll use my spoon and get the rest of the rice out. Okay, so I've got a second bowl to put my, oh, some of the water's still coming out, to put my rice in. And now I'm going to put it back to my cleaned measuring jug, and we've got slightly less than 200, so about 160, so we've got to measure and I'm shaking it around. We've got this solution of salty water left over. Okay, now, I want you to pause the video again. I want you to think, okay, so I used filtration to separate the insoluble substance from my mixture, the rice, because it wasn't able to pass through the holes in that filter paper, my kitchen roll. How can I separate the water from the salt in this? What can I do? Okay, I want you to pause the video and think about that. There are two ways. We can evaporate, okay, with gentle heating, just background room temperature will evaporate the water over a long time, or we could cause the water to boil. So we have to cause the water to evaporate and change from a liquid into a gas. Okay, and we're separating this time based on the boiling point. The boiling point of water is much lower, it's only 100 degrees, than the boiling point of salt. Salt will boil if we heat it hot enough, okay, but it'd be very difficult to do on a normal cooker. Okay, I don't even think it would be possible. I think a cooker would break before the salt would even melt, let alone evaporate. Okay, now, like I say, there's two ways we can do it, and it's going to be up to you which one you choose. Okay, if you choose evaporation, you're going to need some kind of maybe a saucer or a little side plate where you can put your solution and you can leave it on a windowsill out in the sun and it will evaporate away and you'll be left with the salt behind. Okay, that's one method that you can do. The other method, as I carefully pour this back into my measuring cylinder, the other method is to use a pot and the cooker. Okay, now it's when you heat things, I don't mean to be patronising, but when you heat things, they get hot. If you touch things that are hot, you get burnt. Don't touch things that you've heated. You'll get burnt. I don't want anybody to come back to me saying, oh, Mr. Stewart got us to do this practical and I got hurt because I was touching the pot when I'd just been heating it and it hurt my finger. I don't want to hear any of those kinds of stories. I want you to be safe when you're doing this. Okay, so I've transferred the water into my pot. The next stage is to heat it. So boys and girls, I've set up my pot with the salt in it and the water in it as a solution, and now I'm heating. Okay, and it's going to take some time. Now we're going to boil the water to the point where it evaporates. You need to be careful and stop heating, okay, when the water has all evaporated. It's probably even best practice to turn the heating off a little bit before then. Okay, I'll show you what I mean. Now I'm going to speed the video up here, if I can figure out how to do it. I'm going to speed the video up here and give you kind of a time-lapse picture of this water boiling and getting hot, and then showing what's left over. If you've got to this stage and you can hear it hissing, okay, make sure your heat is now turned off, okay, because you don't want to burn your pot. Now, okay, boys and girls, I've got my pot now that's cooled down, and I've got just the salt left at the bottom. Okay, here's a spoon of that, you can have a look. Now, this should be almost pure salt. Should almost be pure. Okay, and I've managed to separate my water, my out-of-date risotto rice, and my fancy expensive salt, and got my salt back. Okay, and I've used filtering to remove the insoluble part of my mixture, and I've used evaporation to separate by boiling points. Okay, now if it's safe for you to give this a go at home, by all means do so, and I'd love to see some pictures uploaded, or even a video if you wanted to, uploaded of how you were able to separate your mixture. Okay, and what would be lovely, though I haven't done it, is if you can show the final salt next to the separated rice or pasta or couscous or whatever insoluble item you used. Okay, there we go, done.
Okay, so just to summarise, the method for the practical, you want about 200 millilitres of water, maybe a little bit less, 1 to 2 tablespoons of salt or sugar, 1 to 2 tablespoons of rice or pasta or couscous or anything that doesn't dissolve in water. Okay, mix that until the salt or the sugar or whatever it is dissolved, and there's your mixture. Okay, now if you use sugar, you need to be a little bit careful at the latter stage, and I'll explain why in a second. Okay, and then when you're filtering or separating, the first job, you want to filter that mixture. So you're removing the rice, you're removing the couscous or the sand or whatever it is. Okay, you filter that insoluble part out. Then you're going to put it into a container and let it evaporate until you're left with just the salt. Or you use a pot and you heat it like I did in the video. If you're using sugar, okay, you can easily create a melted bit of sugar in the bottom of your pot that can be incredibly difficult to clean for one, and also quite easy to burn yourself on. So if you're using sugar, make sure you turn off the heat well before all the water is evaporated. Okay, it's probably best to use salt to do this experiment. I'm going to say it again because I think it is really important. Turn off the heating before all the water is evaporated. Okay, it's going to make your job easier on the cleanup, which you all have to do if you do the experiment. Okay, make sure the pot is cool. Okay, before you start looking at how much salt you've gone back. Okay, make sure it has gone cold, and you do that by waiting 10, 15, 20 minutes even, maybe even an hour. Okay, just leave the pot there to get completely cold. Okay, a little bit of a hint and a tip for your poster. Something like this would be brilliant, where I've got pictures of my particles in a solid, a liquid and a gas, and all I need to do is just add some labels for some of these arrows. What's happening to these to cause this solid to turn into a liquid? What would be the label I'd write up here? Okay, I hope you have a fantastic half term. I hope you're doing brilliantly at home. Take care of each other, take care of your families, and bye bye.